Welcome. We'd like to consider an example of a quadratic equation that's a little bit different from our previous examples. We talked quite a bit about solving a quadratic equation using the zero product property. And we can use the zero product property when the quadratic factors. Here, since we have a coefficient of 1, we'd be looking for two numbers that multiply to 13 and add to positive 4. 13 is a prime number, so our only possibility is 1 times 13. And 1 plus 13 is 14, not 4. So I can't factor this. Since it doesn't factor with integer coefficients, I would have to take some different approach. And that's precisely why we have developed that method of completing the square. So we'll use the method of completing the square here, as we've been doing in recent examples. So I'm going to subtract 13 from both sides to get x squared plus 4x is equal to a negative 13. And now I want to rewrite it one more time, and maybe I could have done this initially, so that way I can observe the completing of the square. So I have x squared plus 2 times something, that is 2 times 2 times x, and I'm going to add something to complete the square, and this is equal to negative 13 plus I added that something on when I added over here to complete the square. In order to hold the equality, of course, I added over here as well. Let's see here. Okay. You might be wondering, hopefully you recall at this point, but you might be wondering why I wrote it in this way. So let's just recall that if I have x plus b squared, which is my desired format, I'd like to write it in this way so I can square root both sides. This is x squared plus 2bx plus b squared. And I need to add b squared to both sides, but I need to know what b is. Well, this term, this x term, its coefficient should be 2 times b. So 2 times b. My b value thus is 2. So I'm adding 2 squared to both sides. 2 squared is 4. On the left-hand side, I don't actually have to do anything. I don't have to add or observe that 2 squared is 4. None of that. I can just simply observe that I've completed the square and that the square should be x plus b, which is 2 in this case, squared. On the right-hand side, I do need to recognize that 2 squared is 4, but I can simply say that negative 13 plus 4 is a negative 9. Now we should have some red flags appearing. Well, that's a negative number. That's a problem, right? When I square something, I get a positive number. How can something squared give me a negative number? And this is where we have to have the introduction of what we call the imaginary unit I. So I'm going to go ahead and manipulate this and introduce the complex or the imaginary unit I as we work through it. So I'm going to square root both sides as I normally would, which would give me the absolute value of x plus 2 is equal to, now I'm just going to leave it as the square root of negative 9 for a moment, which doesn't make any sense. What I can do is I'm going to split apart that negative from the 9. So I get the absolute value of x plus 2 is equal to the square root of negative 1 times the square root of 9. Now, the square root of 9 is fine. I like it. I love it. Right, we have 3. Square root of 9 is 3. Square root of negative 1 is precisely the problem. But what we do is we define this new imaginary unit I, and it is simply the square root of negative 1. This allows us to say that the absolute value of x plus 2 is equal to the square root of 9 is 3. The square root of negative 1 is I. So what I have here is 3i. Now, it might look a little bit weird, but this is perfectly fine. I is the imaginary unit. It is the square root of negative 1. It's just a number. Don't think too hard about it. Now, we should point out, though, that we call it the imaginary unit, but it's really not that imaginary. It's no more imaginary than square root of 2, for example. Square root of 2 is not something that's actually naturally occurring because we live in a discrete world. So we actually will always have a rational number, a rational measurement, and square root of 2 is not rational. And so the square root of -1 is just as absurd as the square root of 2, if you're curious. Okay, so 3i. Feels weird, but it's okay. This gives us x plus 2 is equal to 3i, or x plus 2 is equal to negative 3i. Right? We don't handle the absolute value equation any differently. We subtract 2 to find x is equal to negative 2 plus 3i, or x is equal to negative 2 minus 3i. So we have this new thing called the imaginary unit. When we have a number that appears in this way, maybe call it a plus bi, this is called a complex number. Right, this whole thing together is called a complex number. I itself is the imaginary unit, and we can have a real number plus a real number multiple of the imaginary unit. And together, these things are called the complex numbers. We don't add the a and b together, right? Has a value, and we're attaching that value to the b. So we can't put that a with it. It's you could think of I as like well, right? We call it the imaginary unit. So units wouldn't match. No unit attached, a unit of I attached. So we can't add those together. They stay separate. If you have any questions about that, feel free to reach out. But this should give us a good idea of what the imaginary unit is and the appearance of a complex number.